Hello, and welcome to Introduction to gRPC. My name is Mark Mandel, and I'm a developer advocate for Google Cloud Platform. Thanks for coming to this presentation, and I look forward to introducing you to gRPC. So, this is what your typical monolithic architecture looks like. You have a web or mobile client that directly accesses a single application. Method calls between systems are made in memory, and everything runs inside a single machine. This can be easy to develop, but can be difficult to scale effectively since everything is so tightly coupled together. We may choose to move to a microservice architecture so that we can scale easier, update each part in isolation, and gain other such benefits. We get an architecture that looks more like this. Multiple machines with multiple services that all talk to each other over the network. So while there are many strong benefits of moving to a microservices architecture, there are also no silver bullets. This means there are trade-offs to make. Microservices give us a higher level of complexity, and there are several inherent challenges with microservices you need to take into account when changing from a monolithic architecture. I won't be covering all of these topics in this talk, but gRPC gives us the tools and capabilities to combat these issues without having to roll our own solutions. gRPC itself is an open source project that comes from Google. Google has been running a microservices architecture internally for over a decade. Google's internal stack relies heavily on utilizing RPCs or remote procedure calls. Every application is built using many RPC services that provide different tiers of functionality. Historically, Google has used an internal system called Stubby as its RPC framework to help combat some of the issues we were looking at just previously. This gave Google a strong basis for RPC and microservices within Google's applications. gRPC is the open sourcing and continued development of Stubby. This makes it available to the rest of the developer community so you can take advantage of it for your own microservices-based applications. So what makes gRPC so effective? Let's look at three of its major pieces. The first part of gRPC is protocol buffers, and specifically version 3 of protocol buffers. Protocol buffers, another open source project by Google, is a language-neutral, platform-neutral, extensible mechanism for quickly serializing structured data in a small binary packet. By default, gRPC uses protocol buffers v3 for data serialization. When working with protocol buffers, we write a .proto file to define the data structures that we will be using in our RPC calls. This also tells protobuf how to serialize this data when sending it over the wire. This results in small data packets being sent over the network, which keeps your RPC calls fast as there is less data to transmit. It also makes sure your code executes faster, as it spends less time serializing and deserializing the data that is being transmitted. Here you can see we are defining a person data structure, with a name, an ID, and multiple phone numbers of different types. Along with data structures, we can also define RPC functions in the services section of the proto file. There are several types of RPC calls available. As we can see in Get Features, we can do the standard synchronous request-response model, but we can also do more advanced types of RPC calls, such as with Route Chat, where we can send information via bidirectional streams in a completely asynchronous way. From these proto files, we were able to use the gRPC tooling to generate both clients and server-side code that handles all the technical details of the RPC invocation, data serialization, transmission, and error handling. This means we can focus on the logic of our application rather than worry about those implementation details. The next part is that gRPC uses HTTP2. So why does gRPC use HTTP2? The first advantage of HTTP2 gives you over HTTP1 is speed. Here is a demo you can do for yourself right now, or any time that you like. We are downloading an image of a gopher, which has been cut into multiple tiles. You can see on the left the connection to the HTTP 1.1 server. On the right, we can see the same set of images display almost instantly. This is the power of HTTP2. HTTP2 gives us multiplexing. Therefore, multiple gRPC calls can communicate over a single TCP/IP connection, without the overhead of disconnecting and reconnecting over and over again, as HTTP1 will do for each request. This removes a huge overhead from traditional HTTP forms of communication. HTTP2 also has bidirectional streaming built in. This means gRPC can send asynchronous, non-blocking data up and down, such as the RPC example we saw earlier, without having to resort to much slower techniques like HTTP long polling. A gRPC client can then send data to the server, and the server can send data to the client in a completely asynchronous manner. This means that doing real-time streaming communication over a microservices architecture is exceptionally easy to implement in our applications. Security is always a huge concern with any application, and microservice architecture is no exception. HTTP2 and gRPC work over HTTPS, so we can use the battle-tested security of TLS to ensure that our RPC calls are also secure. Finally, one of the big advantages of a microservices architecture is using different languages for different services. gRPC works across multiple languages and platforms. This is not just includes traditional clients and servers, but mobile phones and embedded devices as well. Currently, there is support for 10 languages: Go, Ruby, PHP, Java and Android, C, C++, C#, Objective-C, Python, and Node.js. The best part is that gRPC is not just a library, but tooling as well. Once you have your protofile defined, you can generate client and server stubs for all of those languages, allowing your RPC services to use a single API no matter what language they are written in. This means you can choose the right tool for the job when building your microservices. You aren't locked into one language or platform. gRPC will generate clients and server stubs that are canonically written for the language you want to use, and also take care of the serialization and deserialization of data in a way that your language of choice will understand. There's no need to worry about transport protocols or how data should be sent over the wire. All of this is simply handled for you, and you can focus instead on the logic of your services as you write them. While Stubby originated at Google, gRPC is a true community effort. A wide variety of well-known companies, startups, and projects use gRPC for their microservices needs. Finally, if you're interested in learning more about gRPC, there are links above for the documentation, how-to guides, and sample applications. If you need help and support, there is an active Gitter chat and Google group as well.